Is that you're waiting for another 2-3 seconds?
Yeah, but Anna, so if you just want to put your presentation up because it's dropped out.
I have already up. Can you see or no?
No, so you need to put it back up and then Isabel can start.
Can you see now? No, I don't think so. So let me see first. I'm in the WebEx. Yeah, I'm the WebEx. Okay. Okay. Can you see, Anna?
Perfect. Isabel, all for you now.
Hello, everyone, and welcome to the ABB webinars. I see some people are still logging in. We'll give them a few seconds and we'll get underway. Okay, I think everyone's here. Thank you for everyone for joining us today. My name is Isabel Stope, and I would like to officially welcome you to SSC 600, Smart Substation Control and Protection, one device for the whole substation, presented by Anisur Rahman. Before we start, 6 quick housekeeping rules. On your screen in front of you is the presentation on the left, and to your right is your control panel. For any issues relating to connectivity, you can contact the host by using the chat box by clicking on the balloon symbol at the bottom menu on your screen. Feel free to ask your questions during the presentation by typing in your questions in the Q&A box on that control panel. Please make sure that you select host when you send the questions through. We will address all raised questions at the end of the presentation, and should we run out of time, Anisur will respond offline. You have all been muted by design, and the webinar is being recorded and will be made available after. After the end of the webinar, there will be a short pop-up survey that will come up on your screen. We'd appreciate if you could take a few minutes to give us your valuable feedback. And with that, I'd like to hand over to Anisur.
Yeah, hi. Good afternoon to all, and thank you very much to join with me. My name is Anisur Rahman, and I am the Product and Solution Manager of Distribution Automation Division in ABB Australia. As you know, protection is an integral part of power systems from the beginning. Earlier, the protection system was based on electrical and mechanical mechanism. The power system has been safely operated long ages with these electromechanical protection relays. You can still see many of them in old electrical installation, especially in the old power stations. As the electronic component developed, the protection relay has been improved to electrostatic relays, and as the digital technology has started and computer has been developed, the protection relay become intelligent electronic device, which is called IED. Now, the central protection and control system is not a new concept. The idea started with the beginning of computer development from early 70s. But the idea has not been widely applied since there were no available computer hardware and software or communication technologies to support such an idea. In recent years, the dynamic growth in the signal processing capability of relay platforms and the availability of suitable substation standards such as IEC 61850 have provided a new opportunity to visit the concept of the centralized protection and control system. Today, I'm going to discuss ABB's Smart Substation Control and Protection SSC 600. Let's start. What happened? Yep. Yeah, first of all, I will go through the product introduction, and then I will discuss how this brand new way of thinking help us, mainly how this technology provide centralized protection, control, monitoring, and communication, centralized HMI or web HMI, fault analysis, condition monitoring, easy to use interface, and how it provides backup protection, easy extension, simplified the devices, and the low impedance busbar protection, which is a simplified low impedance busbar protection, and safety, security, and interoperability. And finally, I will go through the digital services and summaries. Yeah, first of all is that centralized protection and control. Before that, I just want to I want to tell some of the recent trend and justification of this new approach. You know that new technology are involved uh, to face challenges of growing complexity in the power network due to private generation, renewable generation, and distributed generations, which changes the power flow from unidirectional to bidirectional to multidirectional in mesh network. While the operational complexity is increasing, the experienced personnel is decreasing. Also, due to the decentralized intelligence, more processed data need to send from substation toward the upper level SCADA or control system. To face this challenge, new approaches are needed in substation automation with low investment to reduce the operational cost. This brand new SSC 600, which is fully based on IEC 61850 standard, help to automate brownfield and greenfield substations. Finally, due to the product lifecycle difference between the primary equipment and the secondary equipment, we need to have some easy way to update the secondary equipment. Let's go through that, how it works. First of all, what does this centralized protection and control mean? In one shot, it means a brand new way of thinking. It does not mean anything actually, how hard I'm saying that brand new way of thinking. Let's see what is the traditional way of protection, control, and measurement in now or in recent years. See, as you see this diagram, yep, the protection, control, and measurement all has been done or we are doing with these protection relays. So every panel has protection relays, which is doing its own protection, control, and measurement. Also the interconnection, interpanel wiring for intertrip and interlock and all this protection blocking, time synchronization, all this interconnection wiring is going across. Now, the centralized protection and control system, the SSC 600, is used only the two equipments. One is the merging unit, another is the SSC. So we are removing all the interpanel wirings, everything, and putting only this very low cost merging unit. And this merging unit actually communicate into the SSC via IEC 61850. IEC 61850 sample value and goose communication between these. No other hardware communication through this Ethernet communication. And this SSC 600 is doing the protection functionality, control functionality, measurement, and all other. We will go the detail on that. So there are two equipment I said. Yep. So the two equipment, one is the merging unit, which is SMU 615 merging unit. It can take the CT, the conventional CT and BT input, also the sensor input, the sensor current and sensor voltage input. Also, it has input output with 3 high-speed output for the arc flash detection and arc flash system element. In addition to that, all our 615, 620, and 640 relays are by default comes with that merging unit. I put here 4 points that all these protection relays, ABB Reliance series protection relays, comes with native IEC 61850 edition 2. What does it mean? It means that you are getting, whether you are asking or not, you are getting all these 4 almost free. That means the goose communication, the merging unit, the sample value, and the PTP time synchronization. So all these 4 is almost free of cost. Let's move on. What's happening? Why this? Yeah. So another equipment is the SSC 600 itself. It is actually, as I mentioned here, it contains 20 IEDs in one device, and it is used for the whole substation, as I showed before, that whole substation protection, control, and measurement. Okay. So this is actually a industrial computer technology, which is high performance computing, which has the capability. Each software each software and hardware is modular, and you can change anytime in its lifetime. Yeah, as I said, the software, it comes with the basic functionality or basic protection functions and 6 of the application packages, which is optional. So this is like our mobile application, mobile app. It's like mobile app you can download and you can start working. The basic protection functionality comes all the current based, voltage based, and frequency based protection. So basically all our protection functions is already included in the basic protection function. But in addition to that, you have the power transformer protection, motor protection, spatial motor protection, that means the generator protection, power quality measurement, and feeder spatial feeder protection, and see extensive earth fault protection and distance protection, fault locator. All these advanced feeder protection is a optional application, and interconnection protection for the renewable and distributed power generation, and on-load tap changer also available. And finally, the busbar protection, as I said, the low impedance busbar protection is also available. Now see customer value. As I said, that is the short introduction of the product. Now I'm going to that to discuss some of the customer value, that what these SSC 600 is providing us, that value our customer or the technology. See, first of all, what customer need and what this SSC 600 provide. Customer need that central protection, that the customer don't need the individual feeder relay, only the central protection system, protection control and measurement system. Then SSC 600 provide all the protection, control, monitoring, supervision, logic programming, setting, configuration, everything in that on device for on substation up to 20 feeders. And it combined the combined and separated, that IEC 61850 network in the process bus and the station bus. Process bus means from the CTBT, it is bringing through 9-2 sample value to the SSC, and also the goose inter-relay, inter-feeders, that goose communication, that means for interlock, for protection, blocking, and all those signals we can send and receive by, we can configure in this SSC 600. And also the visualization of the web HMI and time synchronization by GPS clock. So we can easily understand that if everything is on device, then if that on device is, goes off or something bad, then the whole substation will goes down. Then it is not a good idea. That's why this is the hot swappable hot protection system. So if we implement this PRP network through this redundancy, and then these two SSC can be used standby or hot, we can call it hot redundancy, means if one down, then another is already live with 0 time. Okay. Okay, next advantage or customer value, I would emphasize on this centralized HMI, fault analysis, condition monitoring, and easy to use interface. This is, since the SSC 600 is getting all the data, or it is taking care of the whole substation, why not the whole substation can be viewed in one monitor? And that's why it has the HMI and web HMI. That web HMI can be accessed from your control system or control center, and and the local HMI is in the local. So all the measurement, that signals, LEDs, all you can see in one monitor, on page. So and the logic processing and all these things is already in that device. Okay. Next one is the fault analysis. See, currently, since we have all the 20 relays access, so from this central device we can get the full visibility of the substation, and it has, say, it record all the received 9-2 signal stream, sample values stream. It record up to 512 Boolean signal. That means the binary signal, and all are configurable. Okay, up to 99 latest record stored in compted format. Okay, all these events for the whole substation is recorded and can be seen, and the fault recorder data, all the protection events. So it will give us easy to find the fault and analyze the fault for the whole substation. So if one feeder fault and it affect the other feeder and all, so we can analyze that whole data in one file or in one device. Next one is condition monitoring. We have the condition monitoring in all of our rely on relays, and you can view all these condition monitoring of your breaker, all the breakers in the in one file. See, and the condition monitoring will give us that that what are the breaker number of times it's operate, and even the gas pressure low, or what is the remaining life. You see this remaining life of phase A, phase B, phase C, and the accumulated energies and inactive days, number of operations. So all these detail and condition of the of the circuit breaker can be viewed in this web HMI, and so that you can plan your circuit breaker maintenance and the changing plan. So these all these phasor diagram, the phasor diagram, you can change your all the setting as well from this web HMI. So the web HMI is a full blown web HMI that can be available in the local and also web HMI can be accessed from the central position or central control room. Now, backup protection, bay addition, and device simplification. Three things I just added. There are a lot of advantages, but mainly these three things. Say, if you have existing installation, existing relays here, okay, and you need so you can have the SSC 600 for backup protection of all the feeders, okay, or if you need add a new function, say these relay need a directional protection due to the changes of the network, so you can, and this relay don't have, say this relay don't have any voltage input to have the directional protection. In that case, you can achieve from these and you can implement that into the SSC 600. Also, say hybrid. So if you want to add another, the customer want to extend the network or extend another two feeders. So we don't need that again the protection relay. You just put that new merging unit, two merging unit, and all this protection control and measurement, everything can be done by SSC 600. See, simplification of asset. Simplification is asset means, see, you have, say, 601, Reliance 601 relay, okay, 611 relay, 615 relay, 620 relay, all these different relays you have, or some third-party relays. You can make all these things thrown and put the SMU only one device. So on device can do all these this protection relays function. Okay, so it will reduce your asset register, and it will give you that the storage, the of the asset simple. Okay? So only two devices you can maintain. Now, simplified low impedance busbar protection. So these SSC 600, since it is taking care the whole substation, why not the whole substation busbar protection is done by these SSC 600. That's why this busbar low impedance busbar protection is added into the functions. And so you don't need any extra equipment, any extra wiring, anything. Okay, so and up to 20 bays and 2 protection zones plus the check zone for single and double bus configuration, integrated sensitive earth fault protection as well, and through fault detection and open circuit detection for more safety and security. Okay, let's go through a little bit detail. So if we have a single bus bar with one section, that means no bus sectionalizer. So it is a very simple feed bus bar protection. And see, we have this bus bar protection function block. So it can take up to 20 feeders. This is the PBDF one. This is the IC 62850 naming, and this this zone selection functionality function block. So what you have to do, only if you give this CB1 open and CB one closed and whether the track is open. These three signal to configure to this zone selection function block, it is done. So this 1 to 20, that zone selection function block, and you have done. See, single bus bar with two sections. So section zone A and zone B, and this is the bus sectionalizer. In this case, that you have to do from bus all the zone A relays. You have to put the see this open and close only to assign to the A, all A zone, and B zone you have to put that all these 11 CB11 to CB20 you have to put in the B zone open close, and for this bus bus detection one, section 1, you have to put both. Okay, so this CB10 has to be both assigned in the both A and B. Okay, open for both and close for both, and it will dynamically changes if and the main thing is that the current flowing through the bus sectionalizer is ignored in the check zone calculation by setting this exclude check zone input to true. Now double busbar system. This is a complex, but and to implement this double busbar system, I don't know that you have experience. Whoever have experienced that this is a very complex things we have to do in other relays, and to make the changeover switch. So we have this changeover scheme we have to implement, but in these SSC 600 it is very easy. You know, you have to put these all disconnector A and disconnector B of the feeder 1 you have to assign into here, and similarly all, and the bus section you have to put that bus ICB for both A and B, and you are done. Okay, so all the relevant disconnectors status information must be connected to the configuration to consider dynamic load switching. So these will do the dynamic load switching, which we used to implement by changeover switch, and we have to implement CT here, so that, and the changeover scheme make it is a very complex system to without this SSC 600, and in SSC 600 this is very simplified. That's why we call it simplified busbar protection. See these two you know precaution things. So this check zone and the sensitive earth fault. Check zone, see this is the zone A bus 1 protection, this is bus 2 protection as I show. But for check zone, we had to have another relay, additional relay that can take all these incoming and outgoing feeders to connect like this, and it is a safety precaution that whether there is any switching discrepancy or anything, that it is not a true fault but it is showing as a fault. So to do that we have to implement these, and another relay we have to put, but in as I showed before that it has the check zone functionality, and it can do SSC can do by itself. And this sensitive earth fault, you know that when we implement busbar protection, mainly it is face-to-face protection it covers, but there are some protection, some fault that very low sensitive fault current due to the upstream neutral resistance. So this in the neutral resistance limit the current, earth fault current, to very low. That's why this sensitive earth fault is required in addition to busbar protection to detect that there is a fault which is below the setting of the differential protection, but it is a fault, and we have to always take care of this. Okay, so that's why this sensitive earth fault protection is there, and these are the algorithm inside that will take care by itself. These are the main another two things that through fault detection. So through fault detection algorithm and CT open circuit detection algorithm. So these two algorithm actually, these two before anything to implement this bus zone or any differential protection, we have to make sure that this outside the fault, outside the zone fault, it will not trip. So to make the fault detection confirm, these two is very important algorithm to implement to make this bus zone protection and uh, and and confirm. Now, how this SSC 600 give us this safety, security, and interoperability in addition to all? See, one thing, outdoor breaker. See, we have outdoor switch yard, something like this, and customer don't want, due to safety reason, customer don't want to go to this high voltage circuit, behind this high voltage circuit breaker to open or close, or you don't want to go to that, whether it is strip or to download the COMTRADE file or whatever. So SSC 600 is sitting here, and only merging unit is sitting there, and all these CTVT data is going through this only one cable, fiber optic cable or Ethernet cable, and SSC 600 will show this wave HMI, that what is the condition of that, and you can open or close the breaker from here. You don't need to go to there. And but customer want that, and if you don't use SSC 600, and if you use relay here, then you have to bring again that all the hardware will come from here to here. So that will, all the hardware means the copper wire is coming from here to here. So that the customer want to avoid that due to electromagnetic induction and false tripping and all these things. Okay, so SSC 600 giving us that function. So it is giving us additional safety. Now, interoperability, as one device is maintaining all these data modeling, then goose communication, MMS communication, all happening. Normally for MMS communication, SCADA need to come to every individual relays. Now SCADA want to come only one device, So MMS communication, all giving by all goose configuration, interconnection, interlock, everything is configured in SSC 600. This sample value 9-2 also is configuring that. Time synchronization is doing by the clock, but also it has its own clock, and all the relay even has its own 9-2 clock. All the merging unit also have, and that can be used as a secondary clock. Then cyber security. Additional cyber security is implemented here. It supports the evolving cyber security standard, and it is already tested in our and implemented in the R&D, and it is and also these SSC 600 have separate local interface. So separate local interface, that means the separate port for your single line diagram or HMI. Then the separate engineering interface with DHCP enabled, dynamic, so that dynamically it will change the detect your IP address. Also the separate service interface. So these are the different Ethernet port with its own IP address, and all this port is own IP address. Also, all engineering communication, with this secured HTTP is not a normal HTTP, it is secured HTTP, and all these PRP network also is a separate port. as you see in the right side, that this is the rear port, this is the local port, this is remote port, this is the service port. So these different ports giving us additional security features. Okay, digital service. Since all the whole substation is protection, control, measurement, everything is done by this SSC 600, we can, ABB ability can give us the remote access, and ABB can give you that the digital service from the remote using our ABB platforms. Okay, so you if you have the shortage of the skilled people, then you can get ABB's help or ABB's service from remote, by remote care and all this. So summary, finally, see, if you have existing, I just wanted to emphasize this, if you have existing substation like all is REF 615 and it is communicating through these GPS clock and all these things. So you want the central protection and control, okay? Use the SSC 600. It will give you centralized protection and control for backup protection and additional protection. Also, the main benefit is it will give you the HMI, web HMI, the whole visibility of your substation in one screen. Also, it will give you the low impedance busbar protection, since it is already sitting in the top and getting all. And these things is no additional equipment or no additional things is required. It is giving you the additional protection as the additional protection. And also the backup protection, see, all these backup protection, in addition to its own protection, it will give you the SSC 600 will give you the backup protection. Also the additional protection, as I mentioned before, that if you need additional protection on any of these relay, SSC 600 can provide that on as well. So thank you very much for your patience. If you have any questions, feel free to ask. Thank you, Isabel.
Thank you, Anna, sir. I do have a lot of questions. I've got questions in chat and I've got questions in the Q&A box. So please bear with me. I'll try to go through them all. Just before we start, I just want to remind everybody that you can continue to type in questions, but please do so in the Q&A box and send them to hosts. That would be great. And while you continue, I will start with our first question. The first question is, how many panels can be controlled by one SSC 600?
Yes, it is up to 20. So 20 is the maximum limit, and at this moment. So 20 panel you can control, and you can implement the whole station up to 20 panels.
Okay. Can the SSC 600 work with other EIDs manufactured by other vendors?
Yeah, I think it is IED. So yes, it is, as I mentioned, that all our ABB relays, Reliant relays, have fully native IEC 61850. And so if the other vendor relay give all those facilities, that means it is fully compatible IEC 61850, because IEC 61850 has different compatibility, level 1, level 2, level 3, something like that. And so it has to be the compatible compatibility. And another thing is the merging unit. So it has to be the inbuilt merging unit so that it can send the data through 9-2. Yep.
Thank you. How can we integrate with existing Nickel West substation already in operations without having a shutdown?
Yes, again, that, the ABB, if it is ABB, say I'm thinking that it is all our ABB Reliant relays with 9-2 IEC 61850 9-2. Now, if it is there, then you don't need to do anything. You have to just configured. So configure that and it will be done by itself. So you since it is actually in the communication interface, it is not even it will not do uh, but it depends that what you are trying to do. If you want to implement some protection functions in the SSC 600 and that and your setting is the lower setting than your operating current, then it will trip. So you have to know that what you are doing. That is what it is. But for HMI implementation, suppose you are actually playing with the binary signals and all these measurement values, which is not about the protection. So in that case, you don't need to worry about it will do by itself.
Okay, I hope that answers the question. How do we upload settings? How do we upload setting files during maintenance or during a shutdown? Will it be via the SS600?
Yes, SSC 600, you have to upload that. It is if you have experience with PCM 600, our only one software that can be done by a B. This PCM 600 also used for SSC 600. You don't need any other software. And PCM 600 for the configuration, for engineering, for graphical display configuration. So all HMI configuration, all has to be done by PCM 600. And PCM 600 has that options that to write to the relay. So you have to write to the SSC 600. So basically, you are actually configuring only one device instead of
All
20
right.
devices. Yep.
Okay. Our next question is, are there any problems or requirements of the SS600 LAN connection for supporting sufficient bandwidth with 20 merging units?
As I show in my slide, that this is a industrial grade high processing capabilities computer actually. So so it has enough bandwidth to handle, and that is the reason that it is up to 20 is limit to and it is tested. Though we tested already up to 40 unit, but we limit to 20 so that no problem exists with these bandwidth issues. Okay, so and it is all in this internal LAN. So
All right.
for goose and sample value.
Does it support IEC 61869-9 sample values? For example, samples for seconds instead of samples for cycle, etc.
These things I have to come back. I have to come back to make sure that
No problem. Okay, that can be answered offline once Anissa has had a chance to check it out. I'm sure that will be, we can respond to you offline with that answer. Is the MU merge unit IED, for example, sorry?
Yep, merging unit, yep.
Yeah, and is it able to trip or close the CB itself?
Yes, because it has input and output. So it has 8 input and 10 output. So that all these input can take the status of the breakers and the primary equipment, and it can receive the trip command through goose, and it can trip the breaker by operating the output.
Okay.
So
Now,
yes.
now this is a little bit of a lengthy one. As per my understanding, all the protections are controlled by one SSC600. In case of a sudden failure, the whole switchgear will be shut down. How can we normalize the switchgear?
Yes, that that is a good question, but that's why in my slide I show the redundancy, the parallel redundancy. So it has and I also mentioned that it has separate IP address port, different IP address port, two port for specific for these PRP network. So parallel redundancy, to implement the parallel redundancy, so that if you have that critical sub or something, so that you can have these two of the SSC 600, one will be hot swappable to others. So if one goes down or anything wrong, then the other will take care automatically.
Not a problem. Has this device been tested with NCIT where there is no effect of saturation or opening the CT secondary?
Yeah, as I show that, yes, it has all the algorithm
Okay.
to detect that secondary CT secondary open circuited.
Okay. Let me go to the next one now.
And also this question has it says that NCIT means that it is talking about the sensor. So sensor CT and VT. You know that sensor CT output is millivolt, not the current. So if you implement sensor, that merging unit can take the sensor input as well. So, and sensor, you can keep it open because it is only millivolt. So one of the biggest advantage of using sensor is that you have that no way to have that CT open circuited problem that give us additional safety.
Okay, if we use the SSC 600, we don't have to use a separate REB bus zone protection relay. Is that correct?
Yes, it is correct, because REB is high impedance busbar protection. That is completely, you don't need to. This is low impedance busbar protection, and it is more safe, and you don't need any REB high impedance busbar protection anymore.
And how many? Oh, I think we've got that already. Sorry, no, I'm just getting confused with all the questions. Can we see the HMI from the central control room?
Yes, it is just Ethernet network. So you can you can use your Internet Explorer or Chrome into any computer in the network, same network, and you can type the IP address of the SSC 600, and you will be able to access that web HMI.
Okay. Can the SSC 600 work with other IEDs manufactured? Oh, sorry. I'm sorry. I'm just repeating that question.
You have that question.
Sorry.
No.
Can we use the SSC 600 for existing substations with non-ABB relays?
Yes, that is the same answer. Yes, you can, but you have to make sure that the relay non-ABB relay is fully compatible with IEC 61850, because SSC 600 is actually developed, and it is fully on fully IEC 61850 platform. So it is tested, and it is tested by our R&D, and it's extensively tested. So you have to make sure that whatever ID you are using is compatible with IEC 61850, is the latest substation standard.
Okay. And can the setting files be uploaded to an EID via SSC instead of directly?
Okay, I think the question is...
I'll just repeat what's typed here. It says, can the setting files be uploaded to an EID via the SSC 600 instead of directly?
Yes, you can. Now there are several ways to put that put that setting value. If you have existing setting file already and the CRV file, then you can put your setting into there, and you can import that, and it is done. Or you can use the PCM 600 to to um, to log in from remote, and you can use our web HMI, as I said. So in the web HMI, you can change your setting if you have the privilege, or if you have the permission. That means if you are admin, then you can do admin right. Then you can do that through web HMI.
Okay, this is a new one for you. Can an abnormal noise occurring inside the breaker be monitored? For example, the noise caused by partial discharge or loose connections.
Yes, so this partial discharge is another device. It is not that SSC 600 is monitoring that. So another device, and we have to see that what is that device protocol. That means if it is some protocol has to be there. If it is IC 61850, then no problem. But we have to see what protocol that device we are talking.
If the SSC 600 failure, will the whole substation lose its protection?
As I said, that you have to have that hot swap, another if it is important. Yes, whole substation is unprotected.
Okay.
If you don't have any redundancy.
All right. I'm just going to check now, back to questions. I'm just because people have put their questions in the chat, so I have to toggle back and forth. Let me just double check. So I apologize if I'm asking twice, but I think everyone seems to be happy with their answers. So I think we're all good. Let me have one more here. Is the Busbar differential protection low impedance of high impedance?
It is low impedance.
Okay. I believe we have all, I'll just triple check to make sure there's no more new questions.
And if there is a question, then they can directly come to us by email.
Absolutely. Absolutely. And we will go through all this and answer anyone that I've missed. If I've missed any in the chat, we will address them to Anissa and he can answer offline.
Sure.
Just double checking. Okay, no, I think that is it for today. So let me see. Before we finish, I'd just like to remind everyone that there will be a short survey that will appear on your screen when we close this webinar. We'd really appreciate if you could take a few minutes to give us your feedback. We hope that you have found this webinar useful, and we look forward to seeing you on future webinars, ABB webinars shortly. Thank you very much. Enjoy the rest of your day and stay safe. Thank you, everyone.
And thank you from my side. Thank you from my side as well. And if you have any questions anytime, please to us. Thank you.
Thank you.